Let's go.
Let's go.
You're very familiar with the OT space first.
It's not connected to the internet. It's not connected to anything else.
So the whole story, when we looked at 5 years ago with the low code, no code, really has exploded.
And so for me, it's a transformative technology for the energy sector. It's called rtdip.io.
And we as Acuvate are bringing that to the market with AccuPrism.
Absolutely.
As our enterprise with exactly the same components.
I think for me, that's where it's going. And what it was, you can talk about the energy metaverse, you can talk about digital twins, whatever you mean by that. I think for me, what's going to happen is you're going to have a digital copy of physical reality. And maybe it's about putting it all together. I think
that's what Acuvate does, you know that.
I know.
Hey, Dan, let's first introduce ourselves.
Sounds great.
You start with it, Dan.
Yeah, so I'm
guy over here.
Dan Jeavons. I'm VP for Digital Innovation at Shell.
Okay. And I'm Johan Krebbers. I'm the CTO for Acuvate, well-known global player. So we're going to talk a little bit about what happens in the digital space, and it can be very, very broad, and we just see what comes out of it. Maybe we kick off because you're very familiar with the OT space first.
Yeah, let's do that.
Because let's first meet what OT means for Shell, because many people don't even know what OT is all about. So now, especially OT and the move to digital, because that's an important subject. So maybe you start with that.
Well, of course, it's worth saying as we start this conversation, of course, you and I have a long history in this space working together that goes back a number of years. So, and indeed, many of the ideas we're still working to implement were things that we worked on a number of years ago. And I think the office domain.
People, of course, realize why that is needed. Because if something goes wrong over there in your refinery, then that could be real danger.
Well, that's it. And I think also air gapped, right? So historically, the approach has been, it's offline, it's not connected to the internet, it's not connected to anything else. You want to make sure that you're completely disconnected from the rest of the world. But in reality, of course, it can't be that way because you have to be able to get information about production volumes. You need to be able to take maintenance routines.
And data into your, we're going to talk about AI later, but it's important into your machine learning environment.
Absolutely.
You also need the OT data playing over there.
Exactly. And I think that's been the long-standing problem of how do you securely and reliably connect into the OT space over that air gap and get the data in an accessible and integrated ways. Yeah. And also increasingly, the analogy that I like is the pilot's cockpit versus the control tower. Yeah. Because obviously the pilot flying the plane needs the controls, needs to be able to drive it, just like the operators at the asset. But you also need the control tower to tell them where to go, which maintenance routines to do,
exactly.
How much to invest.
So there's a link between the two.
Exactly. Yeah. And so one of the things that we've been doing is trying to, in an open source, cloud first way, connect that OT environment into the office domain to provide data visibility, and then to allow some of the things that you're talking about, so to enable machine learning on top of that.
Yeah. What are you doing now? Are you also actively involved as Shell in the whole space of OPAS and what have you? The standard technologies now for that OT space. And how is that making progress now? Because that's an important element also for your digital area.
What's interesting is that I see movement. So OPC UA, OPAS, other standards being adopted, but it's also slow. And I think the reason it goes slow is in part because a lot of these environments are quite static, as we were saying. They're quite... Oftentimes, the operational technology is very tightly coupled to the machinery that's embedded in that environment. And so as a result, it's not easy to change and to upgrade it quickly. Yeah. And I think that holds back some of these new standards from being adopted as quickly as we would like them to be. Yeah. But like I said, I do see genuine movement. I think a lot of the suppliers recognize that open format, open integration.
So your prime suppliers will accept that, like the Honeywells of this world and the Yokogawas of this world, the Siemens, you name it.
They're all talking about it. And I think the other thing to say is, of course, and again back to our shared history. There is precedent for it. So WITSML, right, which is in the Wells space, we see that now being very broadly adopted. And of course,
that has taken many years as well.
Many years. And that's the challenge, I think, in the energy space, because it is that fusion of physical and digital that comes together. So often you have to take time because it takes time to get these things embedded. You have to link it to the upgrade cycles of the assets. You often are constrained. The digital speed often reflects the physical speed and the change in the infrastructure.
But of course, when we talk about digital, you often have also agility, fast moving, and
That's
what
right.
have you. And here, that's not in this. Maybe it might be fast moving for the asset, but fast moving for an outsider. Put it that way. Yeah.
And I think that's right. And I think one of the other learnings we've had has been how to decouple that. So how can you allow that to evolve at a pace, but also then create agility and speed by leveraging more cloud native technologies, for example.
In that environment, yeah. And when we talk about OT, of course, you pick up the time series data from OT, maybe event data. Then we come into the other thing we talk about, the whole machine learning environment and also scientific machine learning environment.
Absolutely. Yeah, and I think, there's probably a few things to say. So one of the things that we've been doing is, of course, we've been working hard on connectivity, looking at how we can use open source frameworks to connect into these real-time environments. We're starting that. We're starting to build services around that and really developing that. So that might be, alarms and events data. It might be typically OSI soft Pi, right? Is a classic example where a lot of this data resides. And so we've been, for a long time, connecting into these real-time data
You've been
stores.
successful as Shell. In that space, you've been very successful, and a lead in the whole market, more or less.
I think 3 million sensors and 5 trillion rows of data are all
in one environment.
Yes. We've made it available through Linux Foundation Energy. It's called rtdip.io. You can
and we as Acuvate are bringing that to the market at the AcuPrism.
Absolutely.
As our enterprise with exactly the same components there because of what you guys have done and the scalability of that.
So as we're saying, I think we've come a long way. We've definitely led the way in that space. We've developed an open source framework, which is called rtdip.io, which of course you know all about.
We know all about
Acuvate. We did that together. And I think, just to put it in perspective, in Shell, it's one environment. Rolled out. But
you also don't forget the second part of the environment is SSIP. Because
Absolutely.
You've got two components over there, which both are very important. Especially SSIP is important. We have both embedded, as you know, in our Acuvate Enterprise Data Platform, which we bring into the market for both the energy space and manufacturing space to bring all data together like Shell, exactly like Shell did. But especially the SSIP bit is important to support Aviva Pi as your data interface, as you're getting the data. And Pi, of course, Aviva in the past was our friends in OSI Soft. But bringing that data together is what you guys really did with SSIP and RTDP.
Absolutely. And I think, maybe to put that in context, so the core of it is effectively an extension to Lakehouse. So RTDIP.
Database Lakehouse for people who don't know yet.
Absolutely. So really trying to extend that specifically for time series data. And then to enable standard functions on top of that. And then the SSIP piece is a set of connectors that we've built ourselves, which we're now licensing out to others if they find them useful to help them to adopt and embed RTDIP.
And the two closely work together, of course. One gets the data in, the other one stores the data in the Databricks environment.
Exactly.
What kind of machine learning development do you see in that space? Because now we have the data over there. Now, of course, AI, ML needs to exploit that data. So what do you see happening there?
So I think what's been amazing, and I'll say this very honestly, I think we never envisaged what would happen when we liberated the data.
No, because we just did it. We thought it was useful.
Exactly. And I think what's been fascinating is to see what people have done with it. Of course, as you know, the first example was the obvious one, which is, use it for predictive maintenance. So for those that don't know, we have, 3 million odd pieces of equipment connected all over the world. And those pieces of equipment mostly are okay, but sometimes they have issues, they trip.
But how many, you had also about 3 million tags up in Shell?
Correct. So it's about 3 million sensors that we've connected total. And it's about, we currently are monitoring about 16,000 pieces of equipment. So that puts it in perspective for you.
As part of predictive maintenance.
As part of predictive maintenance.
16,000 across the world.
Which is, to our knowledge, it's one of the largest predictive maintenance anywhere. And by the way, we're sitting here in our technology center in Bangalore. The team that does this sits just down the way here, monitoring.
Also the largest technology center of Shell in the world, of course.
That's right, absolutely.
In Bangalore, in India,
And it's a wonderful place, as you know.
Yes.
But it's been, I think that's been a really successful program.
So what kind of, maybe a little bit more about what kind of other ML are you models are you developing? So predictive maintenance, obvious one. That was and why it was obvious for people who don't know, of course, it's low-hanging fruit.
That's right.
If you can immediately say, I can increase my uptime,
That's right.
you can just translate in real money overnight. Yeah.
And there are common things that go wrong on a regular basis. Valves, rotating equipment. You can pick these things up early, pick the soft signals up using machine learning, and then prevent the failures.
Exactly.
And saves a lot of money. So that's been very successful. Yeah. More recently, we've extended that into the wells space. So WRFM, wells reservoir facility management, for those who aren't familiar with the terminology. And the idea there is very similar. There's a whole series of things that happen where you may want to make interventions in the wells. You may want to change the way you operate the wells based on information flowing from those. Yeah. And machine learning can be used to identify those issues early. But we're also using the same data environment, for example, to monitor wind farms and solar parks.
So same story.
Same story.
You always collect the same type. Well, at the time series data, it might be different time series data, but it's same approach always. Yeah.
And that's been the beauty of it. It's been just as applicable to our wind farms and solar parks as it's been to our
gas platforms, oil platforms, you name it.
Exactly. Yeah. The other one's optimization. So optimization has been a huge part of the story. So we talk about the two sides of the coin, reliability and optimization. Yeah. So reliability, obviously stopping things going wrong. Optimization, looking to tweak parameters and change things.
To get more out of it,
And we've seen, obviously, a number of different things there. Opportunities to reduce CO2 emissions associated with operating facilities, but also to drive additional production out of the same pieces of kit. Yeah. So, we've been working very hard on developing those capabilities. And then the other one is integrity. And again, something that we've worked on together over the years is looking at how we can, for example, improve the way we inspect the facilities. How can we understand where corrosion's happening? Yeah. And all of this data, it's the same data. Yeah. So we're using
different purposes.
Different purposes. Yeah. But all driving that control tower analogy, being able to provide that insight back into the operators.
But of course, you also will, that also comes, then the digital twin comes into the picture.
That's right. Absolutely.
Because there's where the store comes together for that maintenance guy, the operator, the engineer, you name it. Because you've also been quite successful for instance, in Norway and other assets with digital twin deployments.
Yeah, and I mean, to put that in perspective now, so 14 digital twins rolled out across Shell, about 1 million documents, 10,000 users. So let me just unpack what we mean by digital twin a bit. I think the first thing to say is that digital twin for us is more than just a system of record. It's becoming a system of engagement.
I guess the intent always was with Shell, and also still for me today, it becomes the prime interface for your operators, for your maintenance guy, and because that is the first, it brings the whole store together. Well, and that was always the intent when we brought it in.
And you'd be proud. I mean, one of the things that I did recently is I went up to visit Ormen Lange, which is one of our assets in Norway. And when you go into the control room, there's two things. You see the conventional, what's called DCS data capture system, which is there
from Honeywell, wherever the system is.
And then next to that, you have the digital twin, and the operators use both today in parallel within the control room.
That's nice.
Which is really nice to see, because that was the ultimate vision, which is you have both the controls and the control tower visible in the same environment with the work processes, and that's the big thing. So what we're trying to do is connect the work processes into the twin. So the workflow that you do to monitor equipment, to make sure things are acting reliably, the workflows that you do to optimize the facility, the workflows that you do to prepare and plan the work, the scheduling, the workflow you do if you want to, for example, go in and create an isolation plan. Yeah. Those things are now all done operationally in the twin. So again,
and the twin, I guess also that environment, the twin is setting your at set points, advisory set points back to your other screen in a way, to your DCS environment. Yeah.
So that's where we want to go.
That's why I call advisory set point.
Exactly.
Because the operator can still say, go away. But in principle,
that's where we want to go.
That's where I want to go. Yeah.
And to be clear, we're putting in place the building blocks to do that. So as you know, Shell's led the way in developing advanced process control software.
Yes.
We licensed
for years. Yeah.
Years and years. We licensed our advanced process control to Yokogawa. Product now known as PACE, available in the market to optimize the way in which the asset works. And so what we're looking to do now is connect all of that. So indeed, the work processes around the optimization and the recommendations, they all go through the twin. But also, we started talking about scientific machine learning. Yeah. The other thing that we're looking at is how can you accelerate those simulations and also improve some of those simulations.
By integrated simulation, I guess, in your digital twin environment.
Right. Yeah, exactly right. And what we've seen, which is really exciting, is that when you start looking at some of the novel methods, so Fourier neural operators, physics-inspired neural networks, which what I describe as theorem-inspired machine learning, which is where you don't have data, but you're doing simulations on the basis of the engineering set points. Using those types of capabilities, what you're then able to do is to run those simulations 10,000 times, a million times faster than we've ever been able to do, and also move into multi-scale, which then starts to create a simulation foundation for your digital twin, which you can then use to start making those recommendations in a very smart way. So that's the vision. That's where we're going.
And also, that's one part of this. And also the other part of this, of course, better forecasting, which you already can do today, your turnarounds.
Absolutely.
Make it shorter because you know exactly what's going to happen. And then the simulation part is also important.
Absolutely. And I think that's starting. I mean, again, so the earliest part for me is now doing the isolation plan. Sounds a stupid thing, but actually everyday work prep and scheduling happening in the twin versus in a standalone, separated Excel environment.
Far away from reality.
Exactly. That's a huge change. And so even those kind of things now starting to see the operational processes get embedded in the twin. And then, of course, the updates, because it's all about data quality as well. That happening.
But it happens now, of course, because people see the impact.
That's right.
Why is data quality often, I always say, not done? Because people who have to maintain the data get no benefit from maintaining the data.
That's right.
But now, of course, with this twin, if you didn't maintain something, it will kill you and your colleagues.
Absolutely.
More or less.
And I think more than that as well, the other thing that I think is exciting is the way it brings together remote operations with the site operations. So if you look at LNG Canada, which is one of the facilities that's going live right now.
With digital twin,
absolutely. So digital twin is very much the foundation. And what you see is, as they've thought through how they're going to operate the asset, the work processes between the asset and the offshore location, which is in Chennai, all of that is being done in the twin directly.
Oh, nice.
So the work processes that are integrated across geographies.
But the geography play no role here.
That's right.
Because it's all in the one, but whilst they are many, many, many hours apart.
Exactly. And I think that's really, so it's almost one of those things. What's exciting is you can see where this is going, but we've also got hard work to do. As you know, going back to where we started the conversation, it takes time. We're going to have to work hard to embed this into
and also, but of course, Canada is a new asset, but we also had the problem, of course, with existing assets where you thought, always remember example in shell environments also, where you thought that, that people use the data for many, many years. And then we come along with AI and then how is that possible? How can the data be so poor?
Exactly. That's exactly right.
But then you figured out, well, it might have been there for many, many years, but hardly being used.
That's right. And I think that's, data quality has been the biggest part of the journey, honestly. And I think also, I would say we've made progress, but we're not there. I mean, there's still work to be done to get our data where it needs to be to allow
especially for existing sites, most likely.
Absolutely. And particularly sites that have been around for a long time. With a new asset like LNGC, you've got a fair chance because you can set things right.
From day one, you use the data to a much large extent than you ever did in existing sites.
Exactly right.
So that will be, so that's what it did. Because although there's a lot of interest in digital twin, it still takes quite a lot of time and effort to get it into. But you also need both on the IT side and the business side, people who have that vision. And Norway was in Shell, I guess, the prime example of that.
Well, in fact, we awarded them Asset of the Year this year in our Shell AI Awards because they've really...
they deserved it.
They deserve it. They've really pushed the boundaries. They challenged us. They challenged the paradigm. And the other thing is that they got their data right. That's been the big thing. They put in discipline in managing their data, rigorously. Also in traditional systems like SAP. And that data foundation is really what's enabled them to now push the boundaries of what can be done.
And be the leading side, of course.
And they are, for example, going back to what you're saying about optimization and set points, they're actually doing that. So they're doing that today.
The advisors are not advisors anymore. They're
taking the advisory. They have human in the loop, but the optimization is done in the twin, and they implement the recommendations. And so
you almost need to have a good reason not to implement. I guess now that's the way it should go, more or less. What's interesting, we've been talking now maybe for half an hour. We have not mentioned the word Gen AI yet.
That's quite unusual for me, actually.
What went wrong here? So you're not doing anything with Gen AI, I guess.
Of course not. No, look, I think well, as you know, I think the important thing to say is for me anyway, Gen AI has been coming for a long time. we've been working hard on natural language processing and
yes,
natural language
and we
generation.
did NLP way before Gen AI.
Absolutely.
Yes,
Absolutely.
Yeah.
And the foundation.
it was hard, but we did do it.
We did.
Yeah.
But I think that stood us in good stead because we had really good understanding of what NLP could and couldn't do, the limitations, the frameworks around how we were going to assure it and assess it.
Yeah.
And so we've been building on that with our Gen AI program. I think what's also important to recognize is that Gen AI is very impactful, but also really in its infancy as a technology.
But or even in today's world, it already has lots of benefits.
Absolutely.
We see in our own environment, to see how many different areas with our customer base we do things, and operational, not pilots, now real operational stuff going out there, and which really benefits people already out there today. And of course, that only gets wider and wider because Gen AI, first people who only looked at almost essentially chatbots, but of course it goes much and much, almost every day it gets further and further and broader in the usage.
Well, and I think, as you say, absolutely. And I think it's only going to get bigger. I mean, for me, the capability that's been unlocked here, the genie's out the bottle, right? It's going to go bigger and bigger. And we'll start to include multi-agent systems with different capabilities, allowing you to fully automate end-to-end workflows. And I don't think that's too far away. Yeah. I think what's interesting though is there's a lot to do to get it right. And maybe I'll talk a little bit about how we've been going about it. Yeah, do that.
That would be interesting, yeah.
Because we were in a fortunate position, as you say, we started NLP very early. And so we had a lot of the foundations in place with the platforms that we'd already invested in. So when things came along in November 22 and suddenly
the world saw the light,
we were then able to quickly react and embed the OpenAI APIs into our own environment, obviously running on Azure, and then make that available through a standard set of frameworks we put together. So we had ChatGPT in shell within 2 or 3 months of when. Nice.
So early last year. Then
yeah, exactly. Very early on. And so we've been experimenting with where are the big use cases. And I think some of them are really obvious. Coding, there's some enormous benefits for folks developing code, and obviously increasingly, being embedded into GitHub and so on. These kind of things are only GitHub Copilot. These things are going to accelerate very rapidly. So we see that. I think also, actually where we've seen the biggest impact and the earliest uptake was in communications. So helping people to draft the first pass of a speech or create internal blog posts or those kind of things. That was where the initial pull.
Because I thought in your case also would be like where we have deployed it also is helping people finding stuff in documents.
Absolutely.
Yeah,
absolutely.
So that is a nightmare as well.
Totally. And again, as you say, search. So starting to extend search with Gen AI capabilities. Yeah. Those things have been very impactful. Interestingly, and this is what I always say to people, it's not all about Gen AI. Some of it is just about doing traditional search right.
Yeah, also true.
And so we've been learning about that as well. And then I think the other areas is supporting customer agents, responding to customers effectively, particularly in languages that they might not be fully fluent in. Also, we've had work where generating, for example, tender first drafts, validating content for our procurement function, those kind of things we've seen really strong.
Because what we also made demos of end-to-end demos where we really did the whole operation driven by Gen AI. That means that the only interface they were using was the Gen AI interface, but behind that, of course, you went into SAP, behind it you went into this, but that is very, very powerful if you can do that. Very
powerful. And talking about what's been very cool is, of course, and again, as you know, we've connected DIY to Gen AI to the data that we talked about and the enablement of that through the Lakehouse architecture. Yeah. And what's been very cool is seeing what people themselves can do now you put that all together. Yeah. So again, I'm talking a bit about Norway because it's fresh in my mind, but one of the great examples there, which we saw, was just a normal engineer who'd taken Power BI plus the Power Platform plus
and made his own
RTDIP plus Gen AI and made his own portal.
He can do that.
He can do it. Yeah. And I think that will happen, the enablement of those types of capabilities. And I think the other thing that I've found is oftentimes it's not my team, us, that comes up with the best ideas. It's the folks who...
because they're solving the problem. What's important in that story, of course, because what we in that story we struggle with, getting the guys access to the data then.
That's right.
because that often fails because
That's
then
right.
he starts doing it off because he can't really do that. That's why that enterprise data platform with things like you guys, it is vitally important.
Fundamental. I mean, it's absolutely fundamental. I think you can't do what we're doing now if you haven't first put in place your common data foundations with some consistency and some common architecture. I mean, we standardized on Lakehouse, as you know, and that's been a really smart move because it's really helped us to drive consistency and interoperability between different data sources from different businesses as well. And so we see that very much as core to the strategy for sure.
Yeah, to underpin that what you just said, that the engineer can do his own thing. So also then it also gives an example that your code. So the whole story, but when we looked at 5 years ago, with the low code, no code really has exploded. Eh?
Absolutely.
Yeah.
And I think, I mean, for me, well, as you know, I've always been a big advocate for this because I genuinely believe the real magic happens when you can connect someone with a problem with someone with a good understanding of the technology.
Yeah.
And what I find
there's no translation needed because
exactly.
Yeah, it's the one person doing it. Yeah.
And that's the beautiful thing is that they can rapidly prototype something and show us what they want.
Yeah.
And that takes out all of the requirements analysis because you can see what they want and then you can figure out how to
make it more efficient, better, whatever it is, or smarter, whatever it is,
And so, I mean, we've been very successful in rolling that out. We've certainly been one of the more, I guess, ubiquitous adopters of the Power Platform.
No, because he so early started with that, with special program, low and no code, and at the time also helped Microsoft even what should be from a data protection point of view and how should you do things, et cetera. Yeah,
and that's been fantastic. And I think building on that, the other thing is that what we've now been able to do is put in place a framework where we say, okay, in this space, which we call the green zone, you can do your own thing.
Yeah.
There's a zone where we need to know what you're doing, which we call the amber zone, where we need to have some supervision. And then there's a red zone where we say, look,
that's an IT zone. Yeah.
You need to have the professionals need to take care of that.
And of course that those boundaries change.
That's right. Absolutely right.
It's never fixed, of course. Yeah.
But that principle of giving people freedom within certain parameters and giving them the opportunity to rapidly prototype, to demonstrate, to work something with their team, to drive value, and then to help that scale. I think that's a fantastic story in general. And I think the more we can do that on common data foundations, using common platforms, the more effective we're going to be.
Because it also, much more easy to go there from your green zone to your red zone if that's where that's right. Needed. Because you're in the red zone, you know exactly what the people want, as you said, in the green zone. Can we talk a little bit also, because that let's talk a little bit about we've spoken about OT, but now Edge is more general, and the reason is because I always say I've spoken about Edge for the last 500 years, but because 500 to 600 years it actually is, but it never has really taken off to the last extent. And my statement today always is, well, it will start taking off because of 5G, low latency. But what do you think in that space?
I think it depends on the domain, right? I think. So let me say a few things. So firstly, I do see it taking off already. Okay. So I see more and more where there are real tangible examples. And again, the example we were talking about earlier today is a good one. Increasingly we see robotics coming in and taking over traditional inspection. Really.
Exactly. Operate around it, you name it.
And that is nothing more than an edge device. I mean, the robot is processing things on the edge.
Yeah, because it's just a transport of sensors almost.
Exactly. Yeah. And so in that sense, that's a great example of where edge is real and happening today. Similarly, we're starting to see real requirements where we have very diverse, complex networks. Yeah. So a couple of areas where that's happening. Of course, Shell has the second largest EV charging network in the world. Yeah. And increasingly, that is an edge technology. Yeah. You need
increasingly, yes.
Increasingly so.
Yeah. Yeah.
So that's, a key area. And then similarly, we also have very remote locations, increasingly much smaller, much more distributed, much more diverse energy assets. And those smaller assets, you can't deploy a full DCS system to support that. Yeah. So you need something that's credible at the edge. I think the question is then, how do you see that edge evolving? And to me, what we're backing is the fact that we will have small compute. So we want to try and minimize the footprint, but also.
But you will have some.
We have some. Yeah. And you want to be able to cloud connect. Yeah. And you want to be able to containerize, and it must have machine learning.
But the way I look at that is, of course, you train in the cloud deploy then
Exactly
in
right.
Kubernetes or whatever
Exactly right.
on the edge, more or less.
Exactly right. And that's very much our philosophy is, train in the cloud, deploy to the edge, and manage from the cloud and have that cloud supervision in place to enable us to deal with multiple edge devices.
Yeah. And that's where we also, NVIDIA will play a role.
For sure.
Because otherwise you don't have the capacity at the edge to really make that
For sure.
that happen.
And back to the robotics example, I mean, that's exactly what we're doing.
Yeah.
I mean, if you talk about, using some of the latest Jetson devices, we're using those today in some of the robotics to deploy some of our machine learning algorithms directly to the robots.
Yeah. We did exactly the same in some of our implementations, and using Jetson as our core for running machine vision in that particular case. Yeah. So you also see it, because also may also link to 5G.
Yeah.
I spent 3 years in Malaysia rolling out 5G. I learned a lot about it because I do developments, that's especially with camera images.
Yeah.
Because you can do real-time data streaming, which there's no other way of doing unless you have fiber networking, which of course often is very expensive. So that's why we're using then 5G as the way of doing that. What are you laughing about that?
No, I mean, I think you're spot on. I mean, I remember, I'm laughing because back in the day, I remember you saying this is what it's going to be, even 5 years ago. And it's amazing to see how far it's come. And as you say, I mean, the speed, the no latency, the real-time component with images, videos, all of that is enabling
many things. Because in manufacturing, we see it with quality control, real-time quality control.
Absolutely.
On a production line without stopping. You make the things happen out there.
And safety. I mean, for us,
same
safety
story.
is the same story. Yeah. Being able to create real-time alerts where we see somebody in line of fire within an environment which is high risk. Being able to look at road safety.
Yeah.
You see the same thing happening, and so that there's so many use cases you can think of where that low latency real-time streaming of audio, video, as well as conventional data streams is going to be absolutely fundamental.
Exactly. And that's where edge plays a role.
That's absolutely.
In that edge story, you mentioned a little bit earlier, also that the open source is to me is vitally important.
Yeah.
No proprietary stuff over
absolutely.
There for connectivity, because it's the only way to fast connect
absolutely.
to the whole massive amount of information out there. Yeah.
Yeah. Well, and this is what we've been pushing, right? So I mean, and I think again, we started this journey together with some of in the early days, and I think as you say, that avoiding the lock-in, being open, transparent, also for security purposes, making sure that the things you're deploying are properly tested and battle-hardened, which tends to happen much better in an open source community, ironically.
Yeah, than in a proprietary environment. Because you got a much big community who also would play and test and will find issues then in any proprietary environment, of course.
And we've been loving what the Linux Foundation have been doing in this space. I mean, they've really, in my mind, been leading the way. I mean, LF Edge and then, of course, Fledge Power, these types of capabilities that they've been developing are really becoming the foundation of the way that we're looking at the future edge. Yeah. And very much, we're working, as you know, with companies like IoTech and others to try to figure out how that's going to evolve. Yeah. At the moment, I will say, it's early stage still, honestly.
Yeah, and we do exactly the same with IoTech because we fit it into our end-to-end framework. We're collecting data, storing the data in AccuPrism, because even if you got the data in Edge, the data still has to go into the day.
That's right.
To your enterprise platform.
And that's really where we're trying to, in the same way I think you are, we're trying to wrapper that and then also connect it into the cloud-based RTDIP environment where you can then start to do your machine learning, and then you can deploy the models back to the edge again.
Bring the whole story together again over there. So, what do you see now? What do you see coming up now? We talked about lots of things.
Yeah.
But what we have not spoken about? You say this is also happening.
I mean, I think, and maybe it's about putting it all together. I think
that's what Acuvate does. You know that.
I know. So, I think what's interesting is, and it's something that I put as our theme for this year at our Changemakers conference here in Bangalore, which is the combination of physical and digital technology coming together. Yeah. Because I think we talked about the slow-moving physical environment that moves slowly, the complex, fast-moving digital environment. How do you bring those two worlds together? I think for me, that's where it's going. And what it was, I mean, you can talk about the energy metaverse, you can talk about digital twins, whatever you mean by that. I think for me, what's going to happen is that you're going to have a digital copy of physical reality. And that might sound, again, very obvious, but it's not. It's the ability to simulate, to integrate.
What makes that difficult because you need to be able to rely on a digital component.
Exactly.
That makes the challenge over there, because if you can't rely on it, you can't simulate, you cannot do this, you cannot do that, you cannot do that.
And that's a data game, but it's also a physics game.
Yeah.
Because you have to have both the physics
Yep.
and the chemistry, ironically, as well as the data, all working together in a consistent and integrated way. And the other thing is, of course, increasingly, and again, we were talking about this earlier today, there's so many cases where you want to be able to recreate the physical reality in a digital world.
Yep.
And again, this is where mixed reality, extended reality, all those things come in, whether that be instructions to allow someone to perform a task in the field, to improve turnaround activity, to train people for safety.
Or remote support, whatever you call it.
Remote support, exactly.
Yeah.
All of those things become really fundamental. And then back to your point, then creating the integrity of that model, physics, data, and chemistry, making sure that all of that works together. That's really where it's going to go. And I think for me, that's why I've been so focused on the combination of what we talked about earlier, scientific machine learning, in conjunction with some of the big data, sensor data, edge device, integration with IT/OT, etc.
They're all building blocks in the whole end story.
And it's just as applicable in so many different parts of the whole story.
And any industry almost.
Absolutely. Yeah. Because I mean, it's equally as applicable for our business in the subsurface as it is
in your refineries, your retail, whatever business you have.
In the wind farms, in the solar parks, everywhere. You can apply the same principles. And so for me, it's a transformative technology for the energy sector. And that's why we focus so much on it the last few years. And I think we are, I can genuinely now say I see a glimpse of it. But it's not.
No, it's only a glimpse.
It's only a glimpse. It's not fully there.
Still in the baby steps behind that. In that respect, it brings that whole story you're talking about.
And I think, but I think what I also see is, and back to the Gen AI topic, I think with Gen AI, it's going to accelerate all of that.
Yeah,
because it's going to accelerate the data ingestion. It's going to accelerate the integration between conventional AI and scientific machine learning. It's going to improve data quality, and of course, it's going to become an interface.
Yeah, at the moment we look at a project for Gen AI to produce your production flows.
Yeah,
the whole end to end.
That's right.
And it's no human intervention asking Gen AI to do it, but Gen AI actually producing it.
And you can see that there's so many scenarios where that can happen if you have the data lined up, if you have the fundamental. Science, the physics, and the chemistry. Gen AI can answer those questions.
Yeah, and also and if you have clear because all of them have particular building blocks, particular components. If we make that clear to Gen AI, they can really. Gen AI can then, in principle, pull that together. That's another thing what Gen AI does. Yeah.
And also sorting out the data, doing data pipelining automatically. Silly use case, but so important because getting the data into these environments. That's part of the challenge.
That's what we said earlier. Gen AI might have been started in chatbots environment, but of course goes.
That's right.
All the way back. To the whole space. Hey, Dan, it was very good to talk to you. Nice to talk again, and very interesting. And we're still very much aligned on the approach. Yeah.
Well, just thanks for having me, and it's great. I love catching up. Also,
it's good.
Really cool to hear the great work that you're doing at Acuvate.
Wonderful company. Don't forget.
And thank you for supporting some of the open source work that we're doing as well. We really appreciate it.
No, of course. Very important. Hey, thanks. Thank you helping us as well, helping Shell helping us as a company as well. Much appreciated. And we'll meet again, of course. So thank you very much for your time.
Thanks so much.
Thanks very much. Okay.